So here we go with more quadratic equations. In this problem, we're going to try to factor each expression completely. This is a U-try. Do you guys want to try this, or do you want to work through it together first? Work together this time? When it says completely in the directions, that is kind of a hint for watch out, don't stop too soon, is kind of what that means. So we're going to go ahead and try to factor. When we see this direction, factor, I'm trying to teach you guys to think to do something first every time. What is that? When you see the word factor in directions, what should you think first? Yeah, what can I take out? So what can I get out of a 4, a 20, and a 24? A 4. So let's get that out. Okay, this problem doesn't require the use of the technique with the box, the AC method, because there's a 1 right here, a 1n squared. So we can do this the easier way. All we need to do is look at the factors of this last number, which are 1 and 6 and 2 and 3, and find the 2 that would give us a sum of 5. Yeah, it'll be -5, but well, I don't do it. You can do it that way, that's fine, but I walk through it just a little differently. So I've got my 2 and 3 will add up to 5, right? Okay, so I've got 4 times, I know I need an n, and I know I need an n, because that'll give me the n squared. I know I can put in the 2 and the 3. The signs on the 2 and the 3 have to be the same, right? To get a positive 6, I have to multiply 2 positives or 2 negatives. But to get those to add up to a -5, like Dustin said, they need to be negatives. So how would we check this? We'd FOIL it out and then multiply the 4 by the result, and we should get back to the 4n squared minus 20n plus 24. Questions? You guys be quiet so I can hear over here. In this case, we add because it says plus. If this said minus, I'd be looking for a difference of 5. So I'd use the 6 and 1 would give me a difference of 5. And then I'd figure out the signs from there. Yeah. Let's see what's next. I think we just have a smorgasbord of different types of problems from this unit. Give this one a try. When you're ready to check your answer with ours, press play. Talk through this. When we read through this problem, we see pretty quickly that we're dealing with a quadratic function that opens down, right? And then we see that it's talking about a maximum in 2 places here. When we're looking at a quadratic function that opens down, it has the basic shape that looks like this, right? Yeah, that's exactly right. We're interested in that vertex point because that vertex point is going to be a maximum. Now for this, it's not an x and a y. What's the x part being replaced by here? T, and then it's P, right? So T represents the ticket price, and P represents the profit. So when it asks me to find the price, right, what am I looking for? T, X, or T. When it asks me to find the profit, I'm looking for the Y value, or the P here, right? So how do I find this X value, which is a T value in this problem? Negative b over 2a, right? So we take t is going to equal negative 600 over 2 times negative 15. That comes out to 20. So what's the max? What price should we charge to get the most money back? $20. And then how do we figure out the maximum profit? Yeah, just put 20 in for t. And that yields, what, $6,050? So $20, if we charge, according to the function, if they charge $20 per ticket, they're going to make the most money they can possibly make. If they charge $30 per ticket, then they're going to be over here somewhere on the parabola. They're not going to make as much money. Why? Because not as many people are going to buy tickets, right? I hope they care about their profit margin. Here's another problem for you guys to try. You're going to express the volume of the shaded pipe in completely factored form. So notice up here you've got little r is the radius of the inner white circle, and big R is the radius all the way out to the edge, and then we've got a height. You're trying to express the volume of the shaded pipe. Okay, the volume of the shaded pipe.
What part's the shaded? The
The yellow stuff is on, it's not the middle. Okay? Give that a shot. Okay. For this, most of you guys remembered, some of you needed a hint, but remember the volume of a cylinder is just the area of the base times the height. The area of the base is a circle, so that's going to be pi r squared. Pi, that's an ugly looking pi. Pi r squared times the height. That's still an ugly looking pi, but that's what we're stuck with. So the way we got to do this is we got the volume of the big cylinder is pi big R squared times the height. But we drilled out that little cylinder in the middle, right? So we got to subtract that out, which is pi little r squared height. Now normally we get down to completely factor this thing. So when we look at that to completely factor it, we say, okay, there's a h in both of these terms, and there's a pi in both these terms. We can take out the pi, take out the h. We got big R squared minus little r squared. Then we should recognize the difference of squares and just take that one more step. Pi h times big R plus little r times big R minus little r. There's completely factored form. So, what do you mean? I factored it to the front. So I took the pi out of this term and out of this term, it came to the front. If I redistributed, right, pi and h times r squared would put me back here. Pi and h times little r squared would put me back here. Yeah. Let's see what's next. In anticipation here. Oh.